Okay, welcome to the part 1 of the chapter 13 on the surface area and volume. Okay, before moving ahead with this, let us first discuss with the unit of measurement. You should always remember that the length is measured in unit, area in square unit, and volume will be in cubic unit. Whatever unit is there, centimeter, meter, or millimeter, whatever it is, length will be in centimeter, area will be centimeter square, volume will be centimeter cubed. Okay, just remember this, that the length is in unit, area will be square unit, and volume will be cubic unit. Okay, now next we'll discuss on these three-dimensional figure which will be come across on this chapter. The first one is a cuboid. What is a cuboid? A cuboid is a box-shaped object which has 6 flat faces and all angles are at right angles. You can see it clearly here in the picture I've drawn for you. This side is also called as the edge of a cuboid. This face, this side is called as, each side will have 6 faces. See, if this is the faces, it's called as the faces. We'll have how many faces all together? 1, 2, 3, 4, 5 and 6 down. 6 faces we will have, and how many vertex? 1, 2, 3, 4, 5, 6, 8 vertex. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertex we will have. And how many edge? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges, 8 vertex, 6 faces. Okay, and the length will be always denoted by L. Breadth, sometimes we are calling as the width, by B, and height of a cuboid by H. And if we denote like this, what will be the area, surface area of a cuboid? We'll have 4 surface area laterally, mean along the side, and total will be 6 faces. Okay, on the lateral side we have this is, if we denote this as the length, this will be the height. L multiply H will have 2 area, one is this side and one is the opposite side, and this face and the other opposite face will have B multiply H, isn't it? That means laterally we'll have 2L multiply H and 2B multiply H, while total surface area will be, along the top will be L multiply B, and down below also, therefore we'll have 2L multiply B. Okay, now the surface area laterally will have 2LH plus 2BH, which is 2H common L plus B, and then total will be 2LH, 2BH and 2LB. Okay, 2LB. Then the total surface area will be, here 2 is common, you will have 2LH, BH and LB. The volume of a cuboid will be given by length multiply breadth multiply height. L, B, H will be the volume of a cuboid. Okay, next we'll discuss with acute. What is acute? Acute is a figure where all the length are equal. When all the length of a side of a cuboid are equal, that is called a cube. Okay, this edge, the length means the edge is the edge of the cube, This, if we denote this by A, this will be also A, this will A, this also will be A. Area of this face will be A multiply A square. How many faces laterally? It have 4 faces, therefore area will be 4A square, while the total surface area will be 6 faces. Area of each faces is A square, therefore will be 6A square, and the volume is length multiply breadth multiply height. A multiply A multiply A, which is A cubed, will be the volume of A cubed. Okay. Next, we'll discuss with the right circular cylinder. A cylinder whose base is a circle is called as a circular cylinder, and if the axis of cylinder is perpendicular to its base, then that cylinder is called a right circular cylinder. This means this height of the cylinder is perpendicular to the base. Base of a circular cylinder will be of a circle, and here on the top also you'll find there is one circle. This means is bounded by 2 circles at the top and the bottom. Now the surface area, the curved surface area of this cylinder will be the circumference of this circle multiplied by h. What is circumference circle? Circumference circle is 2 pi r, and if we find the curved surface area of this cylinder will be 2 pi r multiplied by h, which will give us the curved surface area of the cylinder. And the volume, what will be the volume? The volume will be the area of this same circle multiplied by h, which will be pi r square is the area of circle multiplied by h, will give you the volume of the cylinder. Okay, now it is very easy to remember this, because 2 pi r is the circumference multiplied by h will give you the curved surface area. Pi r square is the area of the circle, just multiply by h will give you the volume of the cylinder. Okay, now the total surface area. What will be the total surface area? Total surface area is the lateral or the curved surface area plus with the area of these 2 circles at the top and the bottom. Curved surface area is 2 pi r multiply h, 2 pi r h plus pi r square plus another pi r square with the circle at the bottom. You will get the total surface area. Okay, total surface area here I've shown you area of 2 circular ends plus the curved surface area. Curved surface area is this one, 2 pi r h plus 2 pi r square, because there are 2 circles. Adding these two, you will get 2 pi r plus h, which will be the total surface area. And now the next is with a hollow right circular cylinder. Okay, now this this cylinder here is the same as the previous one, but the only difference is that here at this center of it is hollow. Okay, maybe we can compare this cylinder as a pipe, water pipe. If you look at the water pipe, there is a hollow at the middle, and the circle that you will find here will not be only one circle. There will be 2 circles circular around each end of the cylinder. On the top and the bottom there will be 2 circles. One is smaller circle and the other is a bigger circle. Now if you consider only this top portion, you will get a ring type here, because here it will be hollow, here will be of a metal, or it will be of a metal, and the area of this ring, just consider on this top portion, area of this ring will be how much? Will be area of the bigger circle minus area of the smaller circle. If we denote R capital for the radius of R capital for the bigger circle and small r for the smaller circle, or the radius of the inner circle, then the area of this ring here will be how much? Pi r square minus pi r square, capital minus small, so the bigger minus the smaller. Okay, here I've shown you, I've drawn you here in another picture. R, capital R is for the radius of the bigger circle, small r is the radius for the smaller circle. Then the area of this ring will be pi r square minus pi r square, where r capital is for bigger radius or external radius, small r is for radius of the smaller circle or inner radius. Okay, now what will be the volume? The volume will be the area of the ring multiplied by h. Just multiply the area of the ring multiplied by h will be the volume of this hollow cylinder. Here the area of the ring is pi. After we taking common r square minus r square, this you will get pi r square minus r square, and if you want to find the volume, just multiply this one by h, would be pi h r square minus r square is the volume. Okay, now the area of the curved surface area, you'll have two curved surface area. One is the inner surface area and one is the outer surface area. The inner surface area, how you'll find? Just as a cylinder, the circumference multiply by h. Inner, for the inner circle, just 2 pi r small multiply by h, and for the outer circle 2 pi r multiply by h, isn't it? Just adding these two, you'll get the area of the curved surface area of a hollow cylinder. Okay, here 2 pi rh plus 2 pi rh, the same thing. One is outer radius and one is inner radius. Just add these two, you'll get 2 pi h r plus r. If you take common from here, 2 pi h is common, r plus small r will be you will be getting there as within bracket. Okay, now the total surface area, what will the total surface area? The curved surface area plus the area of this ring, one at the top and one at the bottom. Okay, area of the ring at both ends, that means there will be two ends, area of those ring. We have discussed that area of the ring is pi r square minus r square. There are two, therefore 2 pi r square minus r square. Adding these two, you will get 2 pi r plus r and h plus r minus r. Okay, here how do we arrive at this? Just see, this 2 pi h r plus r is the same thing, and here 2 pi r square minus r square will use with the identity a square minus b square. A square minus b square is how much? A plus b, a minus b. Now if you look at this this first term and second term, 2 pi is common and then r plus r is common, therefore you taking 2 pi r plus r. Here we will have h plus r minus r. Okay, next we have with this right circular cone, little different from the above. Here we'll have the radius of the cone, height of the cone, and length of the slanting height. Okay, in this just look at this diagram. This diagram is as we have discussed, is right circular cone, when we say right circular cone, that means this perpendicular, this height should be perpendicular to the base of the cone. Okay, this axis we can call as the axis. This axis should be perpendicular to the base of the cone. That means the angle between these two should be 90 degree. And if this is 90 degree, we can utilize the Pythagoras theorem here. The square of hypotenuse is equal to the square of the sum of the square on the other two sides. Just look at this triangle. This is the side opposite to the right angle. Therefore, L square will be h square plus r square, which implies that L should be the square root of the sum of these two sides. L square equal h square plus r square using Pythagoras theorem, which implies that L should be root over of h square plus r square. And the volume of this is you just have to remember that the volume is 1/3 of the volume of a cylinder. Is 1/3. Pi r square h is the volume of the cylinder. 1/3 of the volume of cylinder will be the volume of a cone. Okay, just if you remember the area on the volume of a cylinder, it is pi r square h, area of circle multiplied by h, that is the area of cylinder, and 1/3 of that will be the area of a cone. Now the curved surface area of the cone will be given by pi r l, where L is the slanting height. Okay, now from this step we have calculated that L should be root over of h square plus r square. Therefore, instead of if L is not given, we can also write the curved surface area to be pi r. Instead of L, we can substitute root over of h square plus r square. Is the same thing. Curved surface area, you can either write pi r l, or with this one, if the length of slanting height is given, then no need to go for this. Just use with this formula pi r l to get the curved surface area. Otherwise, if the slant height is not given, only the height of the cylinder and the radius of the cylinder is given, then you can use with another formula, which is pi r root over of h square plus r square are the curved surface area of a cone. Now the total surface area is how much? Curved surface area is this curved surface area plus the area of this circle will be the total surface area. Pi r l, curved surface area, plus pi r square, which is the area of the base, circular base, will be the area, total area of a cone, pi r plus l. Okay, next we have with a sphere. What is a sphere? A sphere is just like a ball or a globe. We'll just have only the radius of it, and from this radius we will get the volume, we will get the surface area of a sphere. The volume, you just remember with this formula, 4/3 pi r cubed is the volume, and the surface area will be 4 pi r square. Okay, now hemisphere. What is a hemisphere? Hemisphere is a half of a sphere. Therefore the volume will be half of this. Half of 4/3 will be 2/3. Half of 4 is 2. This will be 2/3 pi r cubed will be the volume, and the surface area is little bit different because why? Surface area will have this curved surface area and the circular area on the top. That means the surface area of a sphere is 4 pi r square. Half of this will be 2 pi r square. Okay, 2 pi r square. And when we come to hemisphere, the total surface area will be 2 pi r square, which is the scope surface area, plus the area of circle, which is pi r square. 2 pi r square plus pi r square, which will be equal to 3 pi r square. Okay, which will be 3 pi r square. Once you remember the area, the surface area of the sphere, then easily you can remember for this hemisphere also. Now with the shell, is the same thing like a hollow cylinder, which the center of the sphere will be hollow, just like the shell of an egg. Okay, shell of an egg. Here in a shell, spherical shell also, there will be two type of radius. One is the outer radius and the other will be the inner radius. Then the volume of the shell will be the volume of the sphere, bigger sphere minus the smaller sphere. 4 by 3 pi r cubed minus 4 by 3 pi r cubed. One is bigger, another is smaller. If you take common from here, you have 4 by 3 pi r cubed minus r cubed is being taken common, is within bracket, and this will be the area or the volume of the shell. Okay, volume of the shell. Now the outer surface area, the same thing as like a sphere. The outer surface area will be with the outer radius. The inner surface area will be with the inner radius. 4 pi r square, 4 pi r square, the same thing, but outer will be with capital R, inner will be with the small r. Okay, this is the end of this part 1. On the next class, we shall discuss with the problem associated with this chapter. Therefore, try to remember all this formula that we have discussed on this class. What is the volume of a cuboid, volume of a cube, then cylinder, hollow cylinder, a cone, sphere. Remember all this formula, and in the next class we shall discuss with you on the problem associated with this chapter. Okay, for the time